Hi everybody, welcome to Chapter 7. Chapter 7 deals with factors and multiples. To start out Chapter 7, we're going to work on Section 7-1 and 7-2 today. 7-1 and 7-2 deal with finding factors. Before I do an example for you on the board, I have a couple reminders that we went over in class to help make this a little bit easier for you. Secondly, we need to remember what a factor is. A factor are the numbers that you multiply together to get your answer. For example, 3 times 2 equals 6. The factors in that problem are both the 3 and the 2 because they're the numbers that I multiplied together. Let me do an example for you on the board. I'm going to try to find all of the factors to come up with an answer of 45. Well, to start, I'm going to use the easiest one we have. 1 times 45. Next, 45 does not end with an even number. Okay, so I know 2 is not going to be a factor. Does 3 work? Well, if I do 3, it goes a little outside my comfort zone because I'm used to skip counting up to 12s. But in this case, if you skip counted by 3s, you would get 3 times 15 equals 45. If I skip count by 4s, I will never get to 45. If I skip count by 5s, I will get to 45. 45 ends with a 5. Use your fourth rule here. If your number ends with a 5 or a 0, then 5 is definitely going to be a factor. 5 times 9 equals 45. 6 is not a factor. The reason 6 is not a factor is because we use rule number 2. When you have both a 2 and a 3 as a factor, then you will have a 6. We don't have any 2's up here. If I skip count by 7s, I'm never going to say 45. If I skip count by 8s, I'm never going to say 45. And here I am at 9, so I don't need to go any further. So the factors of 45 are 1, 45, 3, 15, 5, and 9. These are your factors. This set here is called a factor pair. The reason it's called a factor pair, as you might guess, because it's a pair of factors. 1 and 45 form a pair. 3 and 15 form a pair. And 5 and 9 form a pair. Now, sometimes you might be asked to draw an array to illustrate one of these factor pairs. I'm going to draw an array for 5 times 9. What this means is I have 5 groups, and there's going to be 9 in each group. What I am not drawing is a picture. I'm going to draw an array, which is a nice, neat, uniform picture. So, 5 times 9. 2, 3, 4, 5, 6, 7, 8, 9. There's one group of 9. And directly under those, I'm going to continue to draw my array. 2 groups of 9. Now, you don't always need to use circles. I chose to use circles. You might want to use X's. That's fine also. 3, 4, 5, 6, 7, 8, 9. There you have it. The array for this problem, I have 5 groups. 1, 2, 3, 4, 5, with 9 in each group. Now, you may need to draw a second array for this problem based on the commutative property. It does not change my factors, but if I were to flip-flop my factor pairs, I would draw 9 groups with 5 in each group. I hope this helps you a little bit for both sections 7-1 and 7-2. And thanks for watching.